Alright, so in this video we will be going over some of the vocabulary for circles and the two formulas that we need. So it is necessary that you take out your vocabulary sheet right now. Remember, on the back side of the vocabulary sheet is the formula section. In that section today we will only be working with circles. So on the formula section, please write the formulas in the box that says circles. So the first vocabulary terms are semicircle and quadrant. So semicircle is exactly half of the circle, which is formed by cutting the circle along its diameter. Some of you noticed the other day that if you have the diameter and you cut the circle in half, then you have two equal pieces. This is true for any diameter. It does not have to be the perfect horizontal one or the perfect vertical one in the circle. It can be any diameter, but if you cut it along the diameter, it splits it into two semicircles. The quadrant, just like when we were doing graphing, a quadrant means that you're cutting something into four pieces. So here with circles, a quadrant of a circle is exactly 1/4. And if you notice in this photo here of the quadrant, the two sides, the two straight lines that make up part of that quadrant are the radii. Okay, so both of these are the same length, they're both radius. All right, and so in order to make the quadrant, we need to cut along the radii and not the diameter. The next vocabulary term is something you all have brought up as well when we've been talking about circles, is pi. So in the exploration, you should have seen that when you divided the circumference, which was the arc length in the gizmo, if you divided the arc length by the diameter of any circle, any of those circles that you created, you would always get the number 3.14, 15, 92, 65, etc. This number is a special number because it does not matter whatever circle you're working with. It does not matter the size of the circle. It could be large circles, it could be small circles. It does not matter the circle. If you divide the circumference by the diameter, you will always get this number. It goes on forever and without a pattern. So there's no pattern to the numbers. As we know, sometimes there are patterns. Maybe it would be 3.14, 14, 14, 14, but with pi, there is no pattern. Also, the symbol, okay, some of you, I think, probably recognize this. This is pi. It is a Greek letter. And for the use in class, we will be using the rounded form. So you can't type an infinite number into your calculator. So we will be using the form 3.14. That's the most common one. You'll probably see it on like Alex or other programs or other worksheets. It will say use 3.14 for pi. So now on to some of the formulas. So there's two formulas we need to know. There's circumference and then there's area. Now in the gizmo, you talked about arc length, or you worked with arc length. In the gizmo, that's what they called it. All the way around a circle, the entire arc length would be the circumference. So in the gizmo, you divided the arc length divided by diameter. So here, okay, instead of arc length, I am going to put circumference. So in the gizmo, you did circumference divided by diameter, which gave you pi, right? So in the gizmo, you found that the circumference divided by diameter equaled pi. But what if we want to know the circumference? What if we know the diameter of the circle, but we don't know the circumference of the circle? So what we can do is solve this equation for circumference. So I know we don't have any numbers, but we can still do the same thing we've been doing by solving equations. So here it says divide by diameter. So I'm going to multiply by diameter and multiply by diameter. All right, so here these things cancel out, and we are left with C equals pi. We know what pi is, 3.14, and then we have times diameter. So this is the formula for circumference. Very easy. You guys sort of figured it out on gizmos. It's not that complicated. So on your formula sheet, you need to write this down. Okay, so this is the formula. Circumference equals pi times diameter. All right, so this is where it comes from, and this is the formula that you will need in the future. Area of a circle, I'm just going to give it to you here. All right, so you need to have this down in your formula sheet. So the area of a circle equals pi r squared. Now remember here, when you have two things together, a variable and a number, pi, even though it's a symbol, is still just a number. It's 3.14. When you have those together, it means multiplication. Now here, the r is the only one being squared. So it's 3.14 times the radius squared. So the radius is then squared. We're going to do a couple of examples. All right, the first example, it says, find the circumference of the circle with a radius of 6 centimeters. So here's our circle, excuse my radius, it's not super straight, but we do need to use the formula for circumference. So the formula for circumference is C equals pi times diameter. Now in this case, we're not given the diameter, we're given the radius. So we need to figure out what is the diameter. Remember from last week, if you know the radius, then the diameter is going to be double. So here we know that pi is 3.14 times d. Now d is, if the radius is 6, then the diameter has to be 12. And that will equal the circumference. So here we need to do a little bit of calculation. 3.14 times 12. And it comes out to be C equals, the circumference equals 37.68. Now these problems, you don't have to write them anywhere. There's nowhere for you to write them. You can copy them down on a blank piece of paper, but this video will be available to you through Schoology for the future. Also, so the circumference equals this. We need units. So in the circle, we're working with centimeters. So centimeters. Now, just like when we talked about area and perimeter, perimeter never has the squared part on the units. Same thing with circumference. Circumference is very similar to perimeter, but dealing with circles. And so on the perimeter, on the circumference, there is no centimeters squared. It's just centimeters. Whereas on area, area is the same. Area doesn't matter if it's a triangle, a square, a hexagon, a circle. You will need the centimeters squared on the area. Last problem. Find the area of the circle with diameter of 11. So we need the area formula. So the area formula is A equals pi r squared. We know pi, okay, so we can fill in pi. So A equals 3.14 and times radius. Now in this problem, we are given the diameter of 11. So we need to figure out what is the radius. Again, from last week, we discussed radius and diameter. The diameter is double the radius. So therefore, if the diameter is 11, the radius is half, which would be 5.5. Okay, so we substitute that in. So it's 5.5 squared. Now the squared part only goes with the 5.5. So you need to figure out what 5.5 is squared, because it's not 3.14 times 5.5 squared. No. So here A equals 3.14 times, and I'm going to do 5.5 squared. 5.5 times 5.5 equals 25. So now we need to solve that multiplication. So the area equals 3.14 times 30.25. It equals 94 point, I'm going to round, 99. And again, we need units. So in this case, again, we're working with centimeters. So centimeters. And because it's area, on the units, I need the centimeters squared. So centimeters squared. Okay. All right, you're all set to go with area and circumference of a circle.